All right, so let's go ahead and take a look at the answers here. So first, when you approach one of these graphs, you need to label all your coordinates. So let's see, we got 3, 0 right here. This is on the right side, going down. And it's on the left side, going down. All right, so vertex, that would be that point 3, 0. Domain, so I want the smallest and the largest x. So if I look at these points I made over here, the smallest x value is negative infinity, the biggest is positive infinity. The range, the smallest y value is negative infinity, the largest y value is 0. So 0 with a bracket because it's actually touching 0 right here. This is the line y equals 0 right there, and it's touching that. All right. So interval of increase. So the increasing area on this graph is the left side of this picture. So when I think about it, let's see, the whole left side. So if I shade this area here, because it has a positive slope to it all the time there. So that green area would be denoted by negative infinity up to 3. But also notice that that is simply just the values, negative infinity to 3. So we're going to go ahead and write that, negative infinity to 3. And then the decreasing area would be the 3 again, but this time to positive infinity, because from 3 over, this section over here is decreasing, so from 3 over, okay? So from 3 to the right. All right, x-intercept. There's an x-intercept that is the vertex, actually. So the point 3, 0 is the x-intercept. The y-intercept is right here, so that is 0, negative 6, just recognizing those points. The end behavior, so here's my end behavior right here. As x goes to infinity, that would be this guy. The y value is negative infinity. As x goes to negative infinity, that's this guy. The y value is negative infinity, so it's right there. All right, so this graph over here, I noticed the slope is 2 over 1, 2 over 1 on each of these lines, because if you go ahead and kind of like take a look, you see it's 2 over 1. It's upside down, so I need a negative with a 2, and inside my bars, this graph has been moved, absolute value function has been moved 3 to the right, so x minus 3. It has not been moved up or down, so that's finished. All right, over here, let's see, this is at 1, 3, the vertex. All right, negative infinity to infinity, and this y is positive infinity to positive infinity. All right, domain, again, negative infinity to infinity. That's the smallest and the largest x. The range, though, is from 3 to infinity, because the smallest y value is 3, and the largest y value is infinity. Parentheses here, bracket, because it's touching the 3. So it's touching 3 right here. All right, increasing, that would be the right side of the graph. That side is increasing, so I'm going to go from x is 1 to x is infinity. So remember, we're using our x values, this to the increasing area. And then it's decreasing if I look back from here to here. So that would be negative infinity to 1. Remember, you have to put the smallest thing first. Oops, that should be negative 1, shouldn't it? I need to fix that. Negative 1, negative 1. Sorry about that. All right, x-intercept. There are none. There's no x-intercepts on this picture, but the y-intercept is at 0, 4, right here. All right, end behavior. Both ends are going up. You see both y values are up right here, so it can't go wrong. Just go to infinity. Oh, let's see. So this thing got moved left 1 and up 3. So left 1 would be x plus 1. Up 3 would be plus 3. The slope is still 1 over 1, so that's it. All right, this kind of looks like an absolute value function, even though it's not, because the slopes are different on each side. Like this is a slope of 1, this is a slope of negative 2 over here, but we can still do everything we need. So let's label our points. 2, 3. This one's negative 1, 0. This guy is negative 4 and 5. All right. So domain. Looks like the x's go from negative 4 to 2, brackets. And the range, looks like the smallest y value is 0, the biggest is 5, brackets. Increasing, so that's the right side, so it's this side over here. So it's increasing from negative 1 to 2. This is an interval, parentheses. Decreasing over here, so that's from the x values, negative 4 to negative 1. All right, x-intercept. Looks like negative 1, 0 is an x-intercept. The y-intercept is 0, 1. The y-intercept is right here. Okay. Over on number 4, we're going to be factoring. So 6, 5, and 4 have nothing in common, so I'm going to go ahead and multiply this over. So I get to put a negative 24 in the top of the square, x, and then a 5 here. So this would be 8 minus 5. 8 minus 5 makes 8 minus 3, that is. 8 minus 3 is 5, and 8 times negative 3 is negative 5. That is negative 24. Okay, so I'm going to set this up over here. So I get x plus 8 and x minus 3. But I multiplied by 6, so I had to divide by 6. Remember in class I showed you these things reduce. So this reduces and this reduces, so you have to do that. So you have x plus 4/3, because they both divide by 2. And these both divide by 3, so that would be 1/2. Now I'm ready to say my answer. That would be 3x plus 4 and 2x minus 1. So again, check it. 3x times 2x, there's your 6x squared. Here I'm getting negative 3x and 8x, so that's where this 5x is coming from. And finally, 4 times negative 1 is negative 4. All right, 5, 28, and 15 on letter B, nothing in common, so let's multiply. So that would be 75, kind of a big number, and then negative 28. But think of some money. 25 times 3, 3/4 is 75 cents. So if I do a negative 25 and a negative 3, there's my 28, and there's my 75. All right, let's see. So let me do it over here. So x minus 25 and x minus 3, divide them by 5. All right, so this is kind of a normal one. 25 divided by 5 is 5, and 5 doesn't go into 3, so 5x minus 3. All right, here I got 3 times 4, so I'm going to put a 12 up there and an 8. Everything's positive, so I'll choose 6 and 2. So let's check it out. X plus 6, x plus 2. Divide everything by 4. Now, I do notice that both of these things, these both reduce. So that is going to be x plus 3 over 2 and x plus 1/2. So I need 2x plus 3 and 2x plus 1. And check everything out. 2x times 2x, there's my 4x squared. The outside is 2x, the inside is 6x, so that's why I'm getting 8x, and 3 times 1 is 3. All right, number 5. They do have a GCF, so I'm going to have to pull out a 2. It leaves me x squared minus 18x plus 32. All right, and then for the 32, a negative 18, we'll have to use 16 times 2. 16 times 2 is 32. I'll need them both to be negative to work out. So 2, and then x minus 16, x minus 2, and I'm done. Here, these both divide by 3 and also pull out an x, which leaves me x squared minus 4. Well, this is perfect squares, so remember that that is x plus 2 and x minus 2. Or you can set up the factor x if you want to, negative 4 here and 0 there, and you get plus 2 minus 2 that way. All right, here I'm going to pull out a 3, which leaves me with x squared minus 4x minus 12, and set it up, negative 12 and negative 4. That would leave me with 6 and 2, negative 6 plus 2. All right, so x minus 6, x plus 2, and there we go. All right, for number 6, I'm going to clean this up. So take away 3. So I have 5 and 2x plus 4 equals 15. Let's divide by 5. I have 2x plus 4, and the bars equals 3. So now I'm ready for my two problems. It came out to a positive 3, so 2x plus 4 equals 3, and 2x plus 4 equals negative 3. Over here, take away 4, so I get 2x equals negative 1. Divide, so I get negative 1/2. Here, when I take away 4, I get negative 7, so my answer is negative 7 over 2. On number 7, clean this up, add 7. So I get x plus 3 is less than or equal to 5, and I can go ahead and solve this now. X plus 3 less than or equal to 5. This is a less than, so I'm going to say and. X plus 3, switch it, and make it a negative 5. Take away 3 to solve it, so x is less than or equal to 2. take away 3, so x is greater than or equal to negative 8. So less than or equal to 2 goes to the left, greater than or equal to negative 8 goes to the right, so they meet up. And there we go. All right, so these last two here, we're going to name the transformations. I see 3 of them. So I see this 2, I see this -3, and I see this -4. So let's go ahead. The transformations, this 2 is going to be called a stretch. Stretches everybody twice as high. The x -3 is going to make me move to the right 3, and the -4 makes me move down 4. So right 3 and down 4 is going to be where you're going to start. So that's kind of the most important spot. And then the slope is 2 over 1. So 2 over 1, 2 over 1, 2 over 1. 2 over 1, 2 back 1, up 2 back 1. So you get your V shape. And remember, you can always go to Desmos or your calculator and check those. All right, let's see, the negative. I got 2 things happening here, the negative and the +2. So those 2 things are causing some changes. So we have a reflection over the x-axis, and we have a left 2. So left 2 is the most important thing, and reflection just flip this over. So then my slope is still 1 over 1, 1 over 1, and there we go.